Okay, next we're going to take a look at creating a data frame from information pulled down from the web that's in HTML format. So this function read HTML, read underscore HTML, reads all of the tables found within a particular HTML document. That will only work if the HTML is cleanly formatted. If the HTML has some peculiarities about it, then Beautiful Soup is a better tool for trying to pick apart this slightly imperfect HTML. But we're reasonably confident that the Treasury yield curve information is properly formatted. So let me copy and paste that code. I'm going to use pd.readhtml to suck down the Treasury yield curve information for the year 2019. And that's going to give me back a list, or at least something equivalent to a list, of all of the tables that exist within that web page. Okay? It may take a moment or two or three, but eventually it will return. There we go. And I can discover that this table list only has one item in it. And we would have expected that from previously looking at this web page. Okay, so that means that table list sub 0 is a pandas data frame. And let us obtain that table list sub 0 item. I'm just going to call it df1 gets table list sub 0. And I'm going to make a copy of that so that I don't ruin the original downloaded information in case I make a mess and have to back up and start over again. Okay, so let me check that df1 is in fact a data frame. And it is. Now let me check its shape. And okay, so we've got 250 rows and 20 columns. Now, those 20 columns contain a bunch of fields that we're not actually interested in. The index is simply integer subscripts, so df1.index is a range index object from 0 up to but not including 250 with a step size of 1. df1.columns. All right, so it looks a bit of a mess here because of my font size, but you can see that the first column is the date that we do want, and then we also have columns for the various maturities of these various Treasury notes and bills and bonds. We've got 1 month and 2 months and 3 months up through 30 years. But we've also got these 7 fields that we don't care about. The 20-year, the 30-year, the extrapolation factor. So we're going to get rid of those columns that we don't want. And here is an easy way to do that. If we ask for df1.columns just 1 through 8, sub 1 up to and including sub 8, these are the particular columns that we want to get rid of. And I can confirm that by just displaying them one by one. So for a column in df1.columns 1:8, let me just print each column. There we go. So those are the columns we want to get rid of. And to eliminate one column, we can use the del delete command with df1 subcolumn as the thing that we're getting rid of. So we can simply do that now in a loop for col in these columns we don't want. 1 up to but not including 8. Delete df1 sub col. Shazam. So now if I take a look at, let's take a look at the first 3 rows from the data frame and include all of the columns. All right, so I'm using my iloc with a slice of the first 3 rows and all columns. Cool, and now I have reduced df1 to only having data that I care about. So I've got these column names: date, 1mo, 2mo, 3mo, up through 30 year. And I've got the string for the date and the interest rates, 240 up through 297 for the first row. That is for January 2nd of 2019. And then 242 up through 292 for the second trading day. Now, in this case, I am not using the dates themselves as my data frame index. I'm simply using the integer subscripts 0, 1, 2, and so on as the subscripts for my different trading days. All right, so now that I have got this in a data frame and I have thrown away all the information that I don't want, I can simply say df1.plot, and I will get some kind of default plot. And now, because I'm using idle, my plot did not automatically show up. Let me do a plt.show. Oh, from matplotlib.py plot import. No, I'm doing this. I'm saying this wrong. Import matplotlib.pyplot as plt. Sorry about that. Plot. Oh, goodness. All right, we'll try it again. Not plot. PyPlot. There we go. Now it's going to work. And when I do my plt.show, the plot appears. Okay? And I can tidy up and add, I can add a title and I can add the X and Y dimension titles and so on. But that ought to be a pretty familiar looking plot. Alrighty. So that, if it works, is a great convenient thing. Next up, we're going to take a look at accessing JSON data format. Now, I don't know whether most people pronounce this JSON or JSON. I suppose JSON, but since it's an acronym, I tend to call it JSON. In any event, this is a very tidy little language for describing data, and you can find out all about the JSON data structure format by looking at the json.org webpage. It's really extremely easy to understand. Here I've got a data frame F5, and if I convert that into JSON and I give a JSON file name as my argument, let me show you what happens here. Okay, I have hastily recreated this data frame F5 that we had created earlier in the lecture. So I'm now going to say f5 dot to JSON, and let me give a full path name. I'm just going to put this into f5.json, not JSON, JSON. Okay, and poof, it happened. Let me pull up an ordinary terminal that I have created. Ordinary terminal. This is a Cygwin terminal, a Linux-like interface. And now I can edit this F5 JSON file that I just created. And there it is. Okay, now that format's a little ugly. Let me insert some carriage returns here to make it a little prettier. There we go. So this is a JSON data description. We've got C0 associated with this collection of labels and values, C1 with that collection of labels and values, and so on. And so that is the JSON representation of the columns and rows of that data frame. Next up, we're going to take a look at downloading JSON data from a website. And for this, we're going to look at a very nice website, data.gov.au. Australia, it turns out, was one of the early governments in making all kinds of public information available for download in a neatly organized place. Let me pull up a web browser and we'll take a look at this website. Okay, so I've wrestled my Chrome browser to fit in the recording. Let's go to data.gov.au, see what we can find. Search for data. All right. All right, I'm going to just search for JSON data, see what we find. 1,326 results. Microclimate sensor, City of Canning. Wharf Street Basin water level sensor, City of Canning. Cool. All kinds of neat stuff we can find out about the City of Canning. Now, when I first tried this, rather than the City of Canning, what popped out at the top of the list was a city called Windham. So I'm going to try searching for Windham City Council Asset Inspections. Okay. Bushfire boundaries. Windham City Waste Collection boundaries. And there is, if you poke through the Windham's data, there is something called a smart bin. So let me click on that. Here we go. Windham City Smart Bins. Seems pretty silly. But actually these things are pretty neat. They are waste bins with sensors in them so that the bin itself is able to detect how full it is. Let me select the Windham Smart Bin fill level. And here we have that information. And I would like, I want the JSON version of this. Print this page, files and APIs. JSON. I'll click that. And here we go. This data file can be downloaded from, and we have a URL here. So I've copied and pasted that URL into slide 27, and if we click on that, we will actually get the JSON format information for the smart bins in Windom. Starting out with these three primary keys, type, name, and features, and then on and on from there. For each bin, there is a geometry which tells the latitude and longitude coordinates of the bin. And then there's a properties section which says where the bin is located, what the fill threshold is, and what the current fill level is. So this bin has a fill threshold of 6. The fill level currently is 4. Notice that when I did this, when I was creating my notes, it was probably early in the morning, and so the fill level at that time was a 0. Currently, when I just pulled this data up, it's a 4. So this bin is getting full, but according to the status, it's not yet ready to be emptied. Okay, so that's, let's go look at the Wotton Plaza thing, if I can find it. '79 Wotton Street. Ah, there we go. Wotton Plaza. Okay, now interesting. So this, at this moment, has a fill level of 0, so it's empty. Fill threshold is 8. Status is not ready. I wonder if I have any that have fullness as the status. I should be able to just do a plain text search. So let me try that. So look for... Ah, there we go. Cool. All right. So Aldi G Point Cook, whatever the heck that means. And this thing is full. The fill threshold is 8, and the current fill level is also 8. So I presume that the city of Windom is using this information to send out collection trucks when their bins get full. If they're not, since we have the data, we certainly could do that for them. Okay? And we can read in this JSON stuff into a data frame. SBDF stands for Smart Bin Data Frame. Let me do that. Let me return to my idle interface. And I'm going to copy and paste all this code here. All right. Now, the type of this thing, SBDF, Smart Bin Data Frame, is indeed data frame. BDF.shape is 32 by 3. That means that there are 32 bins, and for each bin, there are 3 attributes. And those attributes were the things that we were looking at. Okay, so for each bin, we have type, geometry, and properties. Oh, my mistake. At the very top level, we have type, name, and features. And then within features, we've got these 32 different bins. So if I ask for the SmartBin data frames columns, I see that the top level columns are type, name, and features. The rows, on the other hand, well, the index, SBDF index, as I said, there are 32 rows from 0 up to 31, one less than 32. And I can display the sub-zero row dot by saying SmartBin data frame loc 0. Okay. Now the indexes here are actually these integers ranging from 0 up through 31. So I can either use loc or iloc here. The effect is the same. I'll just go ahead and use loc. And here we have row 0. Okay. And within row 0 there is a type column. Okay, each column has subcolumns. Type, name, features. And within the features column, there are subcolumns. Type, geometry, and properties, although we're not seeing properties in this output, which is kind of frustrating. Let me ask for sbdf.loc 0. That's item sub 0, and within there, let me ask for a subcolumn, features. And here, now we have type, geometry, properties. And if I'm particularly interested in knowing what the fill threshold, what the fill level, and what the status is, I can further go into that properties subcolumn and look at the various subcolumns of there. So each one of these in JSON, each one of these things, well, this, of course, we've loaded the JSON into Python, into a data frame, and so each one of these things here is actually a dictionary. So these are actual Python dictionaries contained within these objects. So let me look for sbdf.loc sub 0 sub features and sub properties. And now I have just the properties part, and within there I can check for the status. And the status of this SmartBin is not ready. Okay, if I find one that is full, then I will know that I can send a truck to pick that one up. All right, I'm not sure which one of these might be full. Let's see if we can find it. Okay, so for bin in, well, bin is a function for SB in range 32. I know that there are 32 bins. Let me display the status. Print SB, comma, SB.loc SB. All right, so I'm going to print the index number and then a space and then the status. And this loop should tell me the ID number of any bin that is, well, it'll show me the status, and it'll tell me any that are full. Cool. Quite a number of them are full, actually. Okay. I'm not sure what alert is about. That's interesting. Let's take a look at the raw Python again. Sorry, the raw JSON again. Find out what this alert is about. All right, so the third bin had an alert status. Alert. What is alert about? Okay, so the threshold is 8, the level is 0, and we're getting an alert. Maybe alert means that somebody threw a cat into the bin. I don't know. Anyway, okay. So that illustrates the idea of how you can go about sucking JSON data into a data frame. And then once you have it in a data frame, you can step through the items in the data frame using the usual kind of subscripting notation. Next up, we're going to take a look at string handling.